problem number 1. So 3-point charges are placed on the x-axis as shown. Find the net force on the negative 5 microcoulomb charge due to the other two charges. So here we have 3 microcoulomb and the 8 microcoulomb. So the charge in question is actually the negative 5 microcoulomb charge. So this is our charge in question. The negative 5 microcoulomb charge. So before solving the problem, we have to represent 3 microcoulomb as our Q1 and negative 5 microcoulomb as our Q2 and positive 8 microcoulomb as our Q3. Okay, so now since the charge in questions is negative 5 microcoulomb, so we have to make a free body diagram for our negative 5 microcoulombs. So we can represent our negative 5 microcoulomb by a simple point. Okay, and then the force exerted by the positive 3 microcoulomb is pointing in this direction. Okay, so meaning attraction ni 3 microcoulomb. So this is actually the force exerted by the 3 microcoulomb. The next, same gihapon ni 3 microcoulomb since positive attracts negative. So attraction ni positive 8 microcoulomb. So this is the force vector exerted by the 8 microcoulomb. So in our free body diagram, so this one is our force exerted by 3 microcoulomb, and this one is the force exerted by 8 microcoulomb. Okay, and then we have to define the axis. So axis, of course, so we have here your y and your x. So that's actually the usual coordinates that we will use. So now, so to find the net force on the negative 5 microcoulomb, so we just have to add the forces. Okay, so force exerted by the negative 5 microcoulomb is just equal to the force exerted by the 3 microcoulomb plus the force exerted by the 8 microcoulomb. Okay, so this is according to the superposition principle of forces. So we have to solve them individually. So first, ato sang isolve si force exerted by 3 microcoulomb on the negative 5 microcoulomb. So this is actually equal to force vector. We can express this one as components. Okay, so there is no, so can I erase this one? So force 3 microcoulomb, the x component is in the I hat direction, plus the force by the 3 microcoulomb y component j hat. So as you can see here, so makita ninyo that the force is purely horizontal. So meaning that there is no y component. So this is 0 because there is no y component here. So purely horizontal naman siya. So what's left is the x component. So sa inyong vector, you know that the force exerted by the 3 microcoulomb is the x component I hat. Then we have here the magnitude of the force exerted by 3 microcoulomb, then cosine theta, tapos I hat. Okay, diba sa inyong force vector? So unsa man ning theta diri? So theta is actually measured from the positive x-axis padulong sa imuhang force vector. Okay, so tan-aw nato dari. So if we will draw a y-axis with the origin kung asa si negative 5 microcoulomb, makita nimo nga ang angle ni F3 microcoulomb is actually equal to 180 degrees. So I would just put here cosine of 180. So F3 microcoulomb tapos cosine of 180 degrees tapos I hat. Okay, so I hat. So now, so simplify na to. So the force exerted by 3 microcoulomb is actually equal to, so what is the magnitude of the force? So we can use the Coulomb's law. So we have K, so the Q1, Q2, because this is the force exerted by 3 microcoulomb on negative 5 microcoulomb. So ato na siyang represent dito, si Q1 kay 3 microcoulomb tapos si Q2 kay si negative 5 microcoulomb. So 3 square, R squared, then cosine of 180 is negative, so negative 1, but since the theta here represents the direction of your vector, so I can just put the negative inside the I hat. So as you can see also here, na imuhang force vector, force by 3 microcoulomb is pointing in the to the left. So left means negative I hat, diba, sa inyong force. So next, so simplify. So what is K? So K is simply equal to 9 times 10 raised to 9. Then your Q1 is 3 microcoulomb. So remember that the SI unit of charge is coulomb, so not microcoulomb. So you have to convert that one to coulomb. So 3 microcoulomb is basically 3 times 10 to the negative 6 coulomb. Okay? So multiply this one with negative 5. And again, that is microcoulomb, so we have to multiply that one by times 10 to the negative 6 coulomb divided by the distance. So the distance between them is 20 cm. So r squared, the distance between the two charge, is 20 cm, or that in meter, that is 0.2 meter squared. Then absolute value negative I hat. So by calculating that one, the force exerted by the 3 microcoulomb on the negative 5 microcoulomb, so let me just check, times, then multiply with negative 5, so then divided by 0.2 meters squared, so that is basically equal to 3.375. So that is 3.375 Newton in the negative I hat direction. So remember, mawala na ang negative diri because this is in absolute value. So the magnitude is always positive. So this is the force exerted by the 3 microcoulomb. So next, patana, how about the force exerted by the 8 microcoulomb? So force exerted by the 8 microcoulomb. So here, makita nato na imuhang Q3 exerted by Q3 is actually horizontal. So just like sa imong 3 microcoulomb, but this time the angle is 0 degrees. Kay as you can see here. So that is 0 degrees. So we have here the force exerted by the 8 microcoulomb, the x direction, force exerted by 8 microcoulomb, the y, j hat. So there is no so there is no so there is no y direction, so I can just omit that one. So what's left is the force exerted by the 8 microcoulomb, but that is actually the magnitude multiply with the cosine of theta. So theta here is the angle of the 8 microcoulomb. So monang we need to draw a free body diagram first before calculating Coulomb's law. Okay, so I hat here, so I can just put I hat. The next, just like what we did sa ato ang force exerted by 3 microcoulomb, so the magnitude exerted by the the magnitude of the force exerted by the 8 microcoulomb is we just have to use the Coulomb's law. So Q2, Q3, since Q3 is our 8 microcoulomb and Q2 is the negative 5 microcoulomb, and the distance between them, tapos cosine of 0 degrees, I hat. Okay? So simplifying, tanaw na to kung unsa gyud ang magawas nga force. Okay, so K here is, again, this is Coulomb's constant, so 9 times 10 raised to 9. Then your Q2 is negative 5, so convert that one to Coulomb. Then your Q3 is 8 microcoulomb, or positive 8 times 10 to the 6 Coulomb, then divided by the distance. So the distance is 30 cm. So 30 cm in meters is 0.3 meter. So squared. Then cosine of 0 is positive 1. So I hat lang gyapon na siya. So as you can see that since ang imong force sa imong free body diagram, force exerted by the 8 microcoulomb is pointing to the right. So meaning that it is in the positive I hat direction. So please, if wala pa mo kakuan, if you forgot sa inyong mga unit vectors, so please kanang review that one. So how much is the force exerted by the 8 microcoulomb? So I will just compute here in my calculator. So you can compute that one also in your calculator, okay? So walga kuan mo. So we have 8 times 10 to the 6, then divided by 0.3. Okay, sorry, this must be negative 6. That is not, oh wait. So 9 times 10 to the 9, then multiply with 5 times 10 to the negative 6, then multiply again by 8 times 10 to the negative 6, then divided by 0.3 squared, so that is like 4. So meaning that the force exerted by 8 microcoulomb to the negative charge is 4. Okay, so we have here 4 Newton, then I hat. Okay, so nanata. So we have two forces na. So the total force on the negative 5 microcoulomb is, we simply add all of them. So the force exerted by the 3 microcoulomb is 3.375 Newton negative I hat, then here plus 4 Newton positive I hat. Okay, or just simply I hat, it doesn't matter. So since they have the same unit vector, so we can simplify them. So we have 4 Newton minus the 3.375 Newton, because that is natin negative I hat dire. So pagawas na to si I hat, so treat your unit vector just like a number. Okay, so how much is that? So 4 minus 3.375 is actually equal to 0.625 Newton I hat. Okay, so this is actually our answer. So meaning that since the force, the net force on the negative 5 microcoulomb is in positive I hat, so ang nangingibabaw, so what will happen to this one is maadto siya padulong sa positive I hat. So mo na iyahang net force. Okay, so net force in this direction. Okay, since positive I hat man siya, so mas nangingibabaw ang force nga gina-exert ni 8 microcoulomb kay ni 3 microcoulomb. So that's it. So that's sample problem number 1.